Live. Okay, there we go. Okay, today it is 1/21/21. Wow, 1/21/21. Crazy, huh? Okay, so today's objective, what we want to do today is we want to talk about finding linear equations from a scatter plot. Okay? Go and write that down and I'll explain what all that means, okay? So linear in math means it's got to be a straight line. I mean, we've learned about parabolas. Those are curvy, right? Absolute values, those aren't linear, but a linear means it's going to be a straight line. From a scatter plot means usually more than 2 points. So a scatter plot is oftentimes 3 or more points, okay? So if I take a look at this example, you know, there's a line here, right? There's a line here, but they're not perfectly lined up, but there's more than one. But I can definitely try and fit a line in there, right? Same thing with this one. There's a line there, right? But I'd have to try and fit in a line. And this one is terrible. If you're trying to find a straight line from here, this is terrible, right? So, good morning, Mr. Daly. Come on in.
What? I'm just saying hi.
Well, we like saying hi to you. Heck yeah. It's my huge class.
Yeah. Are we missing anybody? Was anybody else that was supposed to be here?
Oh, who knows? How's that for an answer? You know, but I make them, and they know if I don't see them in the morning, I better see them in Zoom.
Just come in the morning. It's easy.
I know, and you learn more, right?
Yeah.
And we just did our homework together. It was awesome.
Yes. It is.
Yes.
Well, hopefully you're still thinking that after the end of the period.
I know, it's all good. Okay, so first of all, we know that a linear function, we could either use our y equals mx plus b. And that's our slope-intercept form, okay? That's called our slope-intercept form. Or we can use our y minus y1 equals our m times our x minus x1. And that's one I like. A lot of kids don't like that one because it's a long point, but I like that one because that's called the point-intercept. No, point slope. Darn me. Point slope form, okay? So if you have a point and a slope, then I like to use this one, okay? Let me highlight these, okay? Those are the two formulas. You can pick one or the other, which one works, okay? We know slope is a fraction. It's a slope m is equal to rise over run. But we have a formula, right? And our formula was sum y2 minus y1 over x2 minus x1. We did that in the warm-up, right? So there it is. Here's our y equals mx plus b. I already got that. Now, the correlation coefficient is this, okay? Let me give you an easy example. So, right now, the COVID vaccination medicine's coming out, right? And then you're thinking to yourself, wow, should I get vaccinated? Is it safe, right? So they do all these tests to see if it's safe, okay? So the better it lines up, the more trustworthy it is, right? So this is a pretty good, the points all lined up pretty good. So R, the symbol R is your symbol for correlation coefficient, okay? That's just the symbol for it. And in this case, if R is equal to 1, it's a perfectly straight line. If R is equal to 1, like for instance, in this graph right here, R would be 1. R would definitely be 1 because that's perfectly straight. See that? This one here is probably close to 1. The correlation coefficient of this one might be 0.9. I'm just going to guess. Might be even 0.95. I'm just going to guess R is equal to, say, 0.95. Okay, it's close to 1. It's close to 1, but it doesn't line up perfectly, right? If I try and draw a line in here, it doesn't hit all the points. Close. So I'm going to say R is maybe 0.9 or 0.95. That's just a guess, okay? Perfect R, correlation coefficient of 1 is if they're all perfect straight. Now if I take a look at this one, maybe 0.8 I don't know. I'm just going to guess. Okay, it's not as good, but it's negative because it's going down. So I'd say the correlation coefficient on this one is about maybe negative 0.8. Okay, it's not as good. It's not as straight, but it is negative because, like negative slope, it's going down, right? This one, terrible. No correlation, so we'd say R is 0. So let's go back to COVID. So if I did my COVID test and these are my results, I would not want to take that medicine. How about you? It's all over the place, right? We'd say there's no correlation, okay? All right, let's go back to number 1, example number 1. So let's find the equation of this line. So first of all, let's draw in the line of best fit. The line of best fit. And I have rulers. If you don't have a ruler, I have rulers over on the table. Okay, so I'm going to try and draw in what I call the line of best fit. Go ahead. Yeah, if you guys want to grab a ruler, go ahead and grab a ruler, okay? And I do have hand sanitizer, but I don't think anybody's touched these for a long time, so don't worry about it. You guys are probably the first ones to touch them in over a year and a half. So if I draw in, so I'm going to draw my line in. I want to draw a straight line somewhere along here. And then I want to try and get it so it kind of goes between all the points. Okay. And to find the equation, I'm going to need 2 points. I'm going to need 2 points. And I think the further apart they are, I'm probably going to grab that point and that point, okay? So we need 2 points. And I'm going to estimate the coordinates. Let's see, the coordinate, I'll call that point A and point B. Am I going too fast? I'm okay? So I just picked those two. I could have maybe picked that point right there also, but I'll just pick these two. So let's see. Now B is like negative 1, 2, 3, 4. 1, 2, 3, 4, 5. So B might be negative 4, negative 5. Point A, let's see. 1, 2, 3, 4, 5, 6, 7, maybe 7, 1, okay? So to find the equation line, first, let's find slope. All right. M is equal to, let's see, my formula is right there, right? So if I call this x1, y1, I call this x2, y2, I can use my slope formula. So I'm going to go a 1 subtract to negative 5 over a 7 subtract to negative 4. Okay, how's that? Double negatives. So I'm going to get 6 over 11, okay? Now I might change that to a decimal. Don't always do that, but eventually when I work with it, I might change it to decimal, okay? Now, I need the equation, so check my notes out. So I've got 2 ways to find the equation, okay? You could use this one, which we've done lots of years, but I'm going to use this one. I like this one. You'll see why I like this one. I think it's easier. So I'm going to write down from equation, I want to use my y minus y1 equals my m times x minus x1. I want to use that equation there to find the equation. Y and x are variables, so I'm going to keep them as variables. But I'm going to use my 7 and 1. I'm going to use 7 and 1 because they're positive numbers. You could use either point, this one or this one. Use either one. I'm going to use 7 and 1 because there's no negatives. How's that sound? Right? We'll get the same answer, but Edie, agree. Let's use the nicer numbers, right? Okay, so I'm going to go y minus 1 equals my 6/11 times x minus 7. Okay? Better get my calculator. All right, so now I'm going to distribute. I'm going to go that times that, that times that. So I'm going to go y minus 1 equals 6/11 x minus, I don't know, hold on, 42 divided by 11, about a 3.8. And then plus 1 to solve for y. Y equals 6/11 x minus a 2.8, okay? Now, is that the exact answer? No, because the points aren't perfectly lined up, but that's a pretty good answer, right? It's a pretty good answer. Okay, you guys good on that? Okay, now example 2. Now, example 2, if I want to find the equation of this one, then first of all, the slope. The slope looks like it, and its rise, looks like it's 10/2. Now, even though the squares are different, the scales are different. Right? This goes by ones. This one goes by tens, right? But I can see by these numbers the slope is up 10/2. So my slope is 5/1. Now, you will have a test at the end of this chapter, and a lot of kids miss this. Words. Words. What does slope mean? Well, what are the words? It's weight per age. See the words? So if you want the words, you just get it from the graph. Okay, what in words? The slope is weight in years. So as you get older, you get heavier, right? So as far as children, right? Now hopefully as grown-ups that stops happening, right? Some people it doesn't, but you know, we're hoping it does. So anyway, in this case, it's going to be my weight, because it's always the y first, per year. So in a sense, we're gaining 5 pounds per year, aren't we? In this one, we're gaining 5 pounds per year, okay? Now, domain and range. This one's a little bit tricky. Domain is all the x values, right? Or how wide is this graph? Well, there's no such thing as negative age. You guys agree with that? So for sure, we got to be greater than 0, okay? But then at the same point, you got to be a little bit careful. And it doesn't show the end, but at what point in time, this is for you, at what point in time do you think you're done growing as a child? Age 16 maybe? Should we say 16, 17? Sometimes girls will stop growing earlier, and boys can grow into their 20s. But let's just say age 16, okay? So I'm going to say the domain is from 0, and I'm going to use A for age, to 16. Because once you hit 16, I think this graph is going to change, right? Now the range. Range has got to be the weight, okay? So it looks like the weight starts at about, maybe about 15, 16 pounds. What'd you guys guess? Would you guess that's about 15 pounds? So I'm going to go range should be 15. That's a big baby. To my weight. And then at 16 years old, what do you think an average weight would be? About 120, 130 pounds? 120 pounds? We'll go 130. How's that? Okay. Domain is my x values, which is age. Range is my y values, which is my weight, from 15 to 130 pounds. And past that, then this graph doesn't apply because you stop growing, right? Okay, turn the page. Okay, example 3. What's the equation of this graph? Well, all right. In this case, I want to use this equation because I can see the slope and I can see the y-intercept, right? So I'm just going to go straight to using my y equals my mx plus b. Okay. I know my b is 20 because the y-intercept is 20. And my slope, let's see, my slope is down, looks like it's down 11 over 4. I think it's down 11 over 4. You guys see that, but it's going down. negative 11 over 4, okay? So my equation would be y equals negative 11 force x plus 20. Okay, now I'm going to change this slightly. I'm going to say that L equals negative 11 force C plus 20. So I changed it slightly so that my equation matches my problem, because we're talking about cups of flour and loaves of bread, not X and Y's, but really cups of flour and loaves of bread, okay? Now, domain range, okay, so let's first look at domain. Domain's the X values. How wide is this? Well, if I go a little further, it sure looks like it's probably going to hit at about 7. So, seems like we're going to make we're going to use anywhere from 0 to 7 cups, right? So the domain is the x's, and on this graph we're going to stop, right? So we're going to use from 0 to 7 cups. Because after that, we're out of bread, okay? Bread remaining, okay? So this problem's like, well, you know, we have 7 cups left. How many loaves of bread can we make? And then we're done. We go home. The range, which is the y values, and on the y values, it's going to be loaves of bread, but we're going to go from 20 to 0. So I'm going to go 0 is less than or equal to my loaves, which is less than or equal to 20. Okay? So my range is my y values. In this case, it's loaves of bread. How am I doing? Okay? All right, example 4. Find the equation that models the number of concert tickets sold with respect to the number of days. A lot of numbers, right? A lot of numbers. So find the equation. Well, I want to use y minus y1, m times x minus x1, okay? And when I look at this thing, I just need 2 points, right? Because I need the slope first. y2 minus y1 over x2 minus x1. So I'm going to pick the first point and the second point. So my points are 376 and 450, okay? 3 days, 76 tickets, 20 days, 450 tickets, okay? And we're going to do what we did before. But I needed to pick 2 points, any 2 points. So x1, y1, x2, y2, right? I'm going to go for the slope, 450 minus 76 over 20 minus 3. Hold on, give me a second. 450 minus 76 is 374 over 17. And this time, it's 22. Cool. It's a nice number. So that means we're selling 22 tickets a day. Really, that's what that means. 22 tickets a day is the slope, okay? So my equation, okay, I want to use this formula. Oh, let's use that number, that point, smaller numbers, right? We could use either point, but let's use that one because it's a smaller number. So I'm going to go y minus 76 equals 22 times x minus 3. And that times that times that. Y minus 76 equals a 22x minus, what's that, 66? Yeah, I should be able to do the math. plus 76 plus 76. Y is equal to a 22x plus 10. We must have, and then the last thing I would do is probably this. I'd probably go tickets is equal to 22 D for days plus 10. I like to use the letters that correspond to the problem. I do. Okay, so that's what I have. Go ahead and stop this. Stop this. Come on, stop. Come on, stop.